Hey everyone, welcome back for Module 2 of the CompTIA A Plus course. Today's module is obviously titled Installing and Configuring PC Components. Now it goes without saying that that's not the only thing this module is going to be about, that is just to give you a general idea. Alright guys, so let's take a bit of a look at some of the main topics we're going to be discussing in this module. This is not the only things we're going to be discussing in this module obviously. So the first main one is using appropriate safety procedures. That can be a lot of things, it's obviously going to include things like electrical safety, things like that. Second main bullet point is PC components, CPUs, motherboards, that kinds of jazz. Third one being common connection interfaces, and the last one being installing peripheral devices. All right, so with all of that out of the way, I think let's jump in and get right to it. Our first one here is using appropriate safety procedures. Now within this category, one of the first things we're going to be having a peek at is local government regulations. Now it's worth noting that this does differ from country to country. It's not going to be the same for all countries. So you'll see there is types of regulations, which includes things like health and safety laws, building codes, and environmental regulations. Now health and safety laws, that's obviously going to differ from country to country. Building codes, each company and each building will have its own little safety codes going for them. And then also lastly, environmental regulations. That is also going to differ from country to country. So you're going to have to go and check in your respective country and also in your building, what are the local regulations, what are the local laws, and then just lastly, what are the dang codes in your building. Then we have OSHA is a prime example of safety regulations for US-based operations. Now this course, being CompTIA, is an American course. Just keep that in mind. And if you are in America, well, great for you. This is going to be a lot easier. If you're not an American citizen, then it's going to be a little bit more tricky. And it is stuff you need to know, in the back of your mind if you intend on writing these exams. But if you're not going to write the exams, then a lot of these things you can actually ignore. It's not necessarily going to be applicable to you. If you're going to write the exam, then it might either be directly applicable to you or indirectly. So one of the first things they've got there is workplace free from recognized hazards. And even though this is based on America, that actually is something that's applicable to most countries. Your workplace needs to be free from recognized hazards. And even if there are no hazards, you need to have warning signs. Then we've got personal protective equipment. So depending on the nature of that company or that business, if personal protective equipment is applicable, that needs to be freely available. At least that's the case in most countries. Last one being communication, which includes things like labels, MSDS, and hazmat training. So if there's anything harmful, anything dangerous, you need to have proper labels. Let's use a simple example. If there is high voltage in a server room, now you guys are probably going to be ending up working in a server room at some point in time. If there's high voltage there somewhere, well, it needs to be clearly labeled as high voltage. That needs to be labeled so that someone doesn't accidentally touch something they're not supposed to. Then we've got employers and employees both have responsibilities. That obviously applies to all countries. Doesn't matter what country you're in, you have responsibility. If you're the employer, you're going to have some responsibilities. If you're the employee, you will have some responsibilities. The employers provide a safe workplace. They generally need to provide you with equipment. So if you need some sort of equipment to do your job safely, that needs to be provided by the employer. You as the employee, just because you work there doesn't mean you are free from responsibilities. You also need to promote a safe behavior. Lead by example is what they say. So they say employees' actions promote safety of themselves and others. So it's not a matter of, no, I saw the other guy do this and do that, so I think I can also go and do that. No, you need to lead by example. If you know something is wrong, if you know something is unsafe, well, then don't do it. Do it the correct way, do it the safe way. Safety's first. All right, so let's take a bit of a peek at health and safety procedures. First one being identify what to do in an emergency. This emergency they're referring to could literally be anything. It's generally going to be something IT related, but it's not limited to IT. It could be something like a fire. It could be something like someone that's accidentally getting electrocuted. It could be an medical emergency. It could be any kind of emergency. So what do you do in the event of one of these emergencies? you need to know. So there needs to be clear procedures in place for what to do in such an event. The second one is identify responsible persons, and this obviously includes things like first responders. You'll find in larger organizations, in some companies, I suppose it depends on the country, but in larger organizations, in some companies, there will normally be dedicated health responders, dedicated fire responders. These are people that actually work there. It could be random staff members. One could be a salesperson, one could be an IT person, one of them could be a manager, but they also happen to be first aid trained and also happen to be trained when it comes to fighting fires. Depending on your country, you might find that in some countries they will require this to be listed somewhere within the walls. So somewhere on some sort of wall, these first aid responders and these firefighter responders, their names needs to be listed on some sort of piece of paper, so that if I don't know everybody in this company, I need to at least know who to go and contact in the event of emergency. I mean, imagine you're working for a company that's got thousands of employees. You don't know everybody in that company. And if someone starts choking on a piece of cookie, who am I going to go and contact? I don't know who to go and contact. So it needs to be quick and easy for me to just look at the sign of what the names are and where these people are so I can go and contact them. Preferably have contact numbers, so that I can call this person if I don't know where they are. Then the third one is identifying hazardous areas and what precautions to go and take. So if there's an area in your company or at your client's company that happens to be very dangerous, you need to identify them and you need to know what actions you need to go and take in those situations. So if it's, for example, a very high voltage area and you absolutely need to go in there, what precautions should you go and take before you can actually go in there? Keep in mind, these areas is not necessarily an area that you're going to be walking into. It could very well be an area that you're working in. It could be something like a printer. A lot of printers, especially if you go look at laser printers, they've got high voltage. And when you open that printer to go and service it in some sort of manner, that is considered, working in an area. So what precautions should you take in an area like that? Well, obviously, if possible, turn off the printer. Preferably unplug it just to be on the safe side. Then we've got describe best practices for use and care of workplace and equipment. Now this can obviously be anything. It could be stuff like just keeping your workplace, obviously clean, making sure there's not stuff lying around. This could be stuff like electrical cables. It could be network cables. Of course, that obviously forms a trip hazard, making sure that you've got proper lighting, just general stuff. Last one here, establish incident reporting procedures. So in the event of an incident, which could literally be just about anything, what is the procedure for reporting such an incident? So incidents could be something like maybe an IT theft, could be digital IT theft, could be physical IT theft, it could be in a medical emergency, could be a fire emergency. So whatever the incident may or may not be, what is the procedure? There needs to be clear procedures in your organization. So if you're going to a company or a client, what are their procedures? If you're working for one specific company, what are their procedures? This normally quite often in most countries will be listed as a clear procedure which is going to be posted against a wall. It's probably going to be a very huge piece of paper that's laminated. They're going to stick it against the wall somewhere so that everybody can see it. It wouldn't surprise me if you would find this in the coffee station. So if your establishment has some sort of little small kitchen perhaps, you might find it on the wall in the kitchen. Clear reporting procedure so people know. It's normally right next to the signs that says no harassment, no bullying, that kinds of nonsense. That's the kind of things you would see. All right, boys and girls, and then we have general emergency procedures. So in the event of an emergency, whatever it may be, if applicable, raise the alarm and contact emergency services. So if it's a medical emergency, you're probably going to contact an ambulance. And while you're at it, you can obviously contact the first aid responders, which are on site. It's not as good as a paramedic, but at least they can get things going. If it's a fire emergency, you're going to call the fire department in your specific country, and you are obviously going to go and contact the fire responders in your building if you happen to have some. Hopefully you do. So what is listed under that category is description of emergency. So if you're going to go and, for example, contact the fire department, you preferably need to give them a description of what the emergency is. It's a fire hazard. What kind of fire is it? Is it an electrical fire? Is it a big fire? Is it a small fire? Where is the fire? What started the fire? Is there any casualties that you're aware of? Give as much information as you can. Same goes with a medical emergency. So you're going to contact an ambulance, you're going to contact the hospital, give a general description of what the problem is. Someone is choking perhaps, they're struggling to breathe. Give a description, as much detail as you possibly can. The location of the emergency, obviously that includes what we just said. The second big bullet point is, if possible, secure the scene. Now notice they said if possible. It's not always going to be possible. So if you are the first responder for this fire, if possible, that means if you are the first responder for this medical emergency or this fire emergency, you can start securing the area. So if it's a fire, you can maybe start grabbing a fire extinguisher. You can start killing the fire where possible, where it's safe to do so. If it's not safe to do so, leave it for the fire department, leave it for the pros. If it's a medical emergency and you happen to be trained with medical, the basics of it at least, you can start with the medical, but leave it for the professionals. Obviously, you don't want to just leave the person there. So if you are trained to do so, you can start on the person, start helping them until at least the first responders can get there. So they mentioned escape routes for fire situations. It's a good idea to know what the escape routes is in a building. Where are they in event of an emergency? So if there happens to be a robbery, if there happens to be a fire situation, where do you and your people go? So know the routes. There's normally clear signs marking these exits in most countries. Disconnect power for electrical shock situations. So in the event of this emergency being electrical related, if possible, turn off the power. There are exceptions. For example, if there's a fire emergency, you also preferably want to go and turn off electricity, because you never know. It could actually make situations worse. So depending on the situation, there's a very good chance you might need to go and trip a circuit breaker somewhere. That's what you want to go and do. And then once again, they mention if you have training, try to start handling the incident. So that goes back to what we said earlier. If you're a firefighter or if you're a first responder for medical, you can try handling the situation, but only if you have been trained. And then lastly, keep calm and don't act rashly. So since we're talking about emergencies, let's have a look at electrical hazards. Most prevalent physical hazard for IT equipment and personnel. Yeah, this is a real pickle. It can either kill you or it's going to break your equipment, one or the other. So when it comes to humans, electrical shock can cause some of the following: muscle spasms, burns, paralysis, cardiac arrest, collateral injuries, or better yet, death by electrocution. So none of that is something that you want or that you want someone else to experience. Other way, at the very least, you're going to have a lawsuit on your hands. So you need to do whatever you can to try and avoid that. Keep equipment away from conductors. Now, the course mentions metal or liquid, but it's obviously not just limited to metal or liquid. Anything that can conduct an electrical current is a conductor. So metal and liquid is just some of the most common things. So if you have a liquid spill somewhere and there's, for example, an electrical cable near that, someone could very easily get electrocuted if they touch that spill. If electrical cable is, for example, touching a piece of metal somewhere along the line, and someone touches that same piece of metal, yeah, I think you guys can do the math. It's not going to end well. All right, so more about electricity. So more specifically, equipment grounding. So ground, for those of you that don't know, a safe path for electrical current to flow away in the event that a device or cable is faulty. So it's very important for something to be grounded. You'll find quite often in some countries, some devices will not be grounded. And it's not because someone forgot to ground it, it actually just comes out like that, especially if it's something that doesn't have a very high ampage. So risky behavior, but that is the behavior for some countries. So they mentioned creates a path of least resistance for electrical current to flow away and cause no damage. If there's no ground, yeah, it's not going to end well. Ground achieved for most PCs by connecting the power cord to an electrical outlet. So what you'll find in some events is, okay, well, I suppose it depends on the country. There will normally be three wires. One will be your live, one will be your neutral, and one is going to be your ground. This might vary from country to country, but generally one is ground. There's going to be a positive and there's going to be a negative in a nutshell. you might need to establish ground for equipment racks or other systems. Yeah, so if you've got equipment racks or other systems, there's actually a lot of things in life where you manually have to go and ground something. So you'll find it on the frame itself, there's like a piece of wire that's basically bolted to the frame. And that piece of wire, which is normally a very thick piece of wire, is normally bolted to the ground or something like that. And that allows it to go and safely flow away in the event of a short circuit or something like that. So yeah, that's something you only see on a very, very large system, like a rack or some kind. Alright guys, so something that you guys most likely know already. Most PCs, and when we say PCs, we're actually talking about desktop PCs here, not laptops. Laptops obviously have very low voltage and low current, but desktop PCs, the majority of them have low voltage and low current. So for the most part, it's not something you need to worry about. You're only going to blow your components, but you're not going to get electrocuted. But there are exceptions. So within the PC itself and just in general in IT. So within the PC itself, you have your PSU, your power supply unit, and here you'll see it's just listed as power supplies. Those is something that you guys should never touch. That's basically the little shiny box that you guys go and plug your electrical cable into. So if you guys are brand stinking new to A+, that little shiny square box that you plug your electrical cable into, that is your PSU, your power supply. And it contains, obviously capacitors and stuff like that. And they generally store very, very high voltages. So that is not something you want to go and play with. They're very easy to go and replace, and they're very cheap to go and replace. So whenever you find a user, or even yourself for that matter, if you've got a power supply that's faulty, the rule of thumb in IT is normally to go and have it replaced. Especially when it comes to your power supply. It's just not worth it. It's going to cost you way more in labor and all of that just to go and replace that. And quite frankly, it's very dangerous. That is only for a qualified electrician. So unless you are a qualified electrician, it is not something you want to go and do. So if a user has a faulty power supply, I would suggest you tell the user, ma'am, sir, we're going to have to replace that power supply. So if it's for your company, you would probably just go and get one out of stock or go and order one. If it's for a client of yours, you're going to have to recommend that they go and buy one themselves, or you can go and buy one for them and you just obviously build them accordingly. So yeah, you don't want to go and touch a power supply. Even if it's plugged out, those capacitors store very large quantities of electricity for a very, very long time. So you'll find that you might have a power supply lying in a box somewhere in your house. It's been there for years, and you might think to yourself, what's the harm? Trust me, it can still either kill you or put you in an intensive care unit. When you've got LCD display inverter card, that's something you'll find in your LCD monitors. They're becoming less and less, common because obviously people are moving to LED nowadays. And then lastly, laser printers. Now, laser printers, if you're going to try and open one, you'll find it all over the laser printers. They normally have these high voltage signs, and they're obviously there for a good reason. So if you find yourself needing to open a laser printer, if at all possible, I highly encourage you to turn it off and also to unplug it, never mind turning it off. Something which is also worth noting, which is not power related, is these laser printers actually get very, very hot. So it's not related to the topic, but it's just a general rule of thumb that I want you guys to be aware of. Do not open a laser printer while it's hot. So unless you know what you're doing, you're going to get burned. So never mind getting electrocuted, you're also going to get burned. So watch out for that. So yeah, they mentioned do not open units that are marked with high voltage. That goes without saying. That applies to anything, whether it be a laser printer, whether it be in a cabinet which has got circuit breakers. Unless you're a qualified electrician or you know what you're doing, then you should not go and open those. Alright guys, so here's a few extra pointers for fire safety. Some of them might be obvious, some of them might be things you haven't thought of. So when excessive current flows through a cable, the cable gets hot. Now, excessive current is normally a very high amount of ampage, is what we call it. So if you've got a very thin electrical cable and you're pulling an excessive amount of electricity through it, so let's say you've got some sort of heater, kettles, maybe it's an iron of some kind, anything that pulls a very large quantity of electricity through a very thin cable is going to make that cable get hot because it's too thin to handle the ampage. So you need to have a higher gauge of cable. I think in some countries they refer to it as a higher gauge of cable. So you get yourself a thicker gauge, or just in general a thicker kind of copper cable. The thicker the cable, the higher ampage it can handle. You'll find it also normally costs you more. Quite often in some countries, if you go and buy yourself a cable, on the packaging it'll tell you what kind of ampage it can handle. The higher the ampage, the more stuff you can load onto it. So yeah, don't think that you can load a lot of stuff onto it if you have a thin cable. It also depends on what the equipment is. You might find you've got a thin cable and you can put 10 items on it because it's 10 items that's very light. They're very light on ampage. Where you might have another cable which is the exact same cable and you can only put one item on it, and that's already going to be more than the 10 other items. It depends on what that item obviously is. So the second point here is adjacent flammable materials could ignite. Yeah, I mean, if you've got a hot cable and you've got something near it that's very flammable, liquid perhaps, yeah, that speaks for itself. Use fire extinguishers designed for electrical fires. Now, depending on your country you're in, you'll find that most common fire extinguishers have some categories written on them. You'll generally find category A, B, C, and D. So make sure you use the right fire extinguisher for the right fire. Obviously, if you have an electrical fire, which is the most common scenario in IT, you don't want to go and use water on that, or some sort of liquid-based fire extinguisher. That's a bad idea because, as we've said earlier, liquid is a conductor. So if you've got an electrical fire, water or liquid is the last thing you want to find yourself using. You're probably going to end up using CO2, carbon dioxide, I think is what they call it. Oh yeah, they mention it on point 4. CO2 extinguishers with a black level or optimal. That's perfect for electrical fires. Dry powder extinguishers can damage electrical equipment, so just be careful when you use them. Try not to get too much of the powder on the electrical equipment unless it can be helped. If the fire is coming out of the electrical equipment, then, well, there's no choice about it. Be sure to cut the power supply. That's assuming it's possible. So if it's possible, try and cut the power supply. So if your PC, for example, is on fire, if a server's on fire or some sort of component, if you have access to the power cable, flip that switch, yank it out. Alternatively, just go and trip the circuit breaker. That might also be a good option. Obviously, it's going to trip a few other things in the building, but at the end of the day, it's lives that's at stake here. Know where the master switches are for the buildings you work in. So whether it be your building, whether it be a building for a client, it's always a good idea to know where the master switches are when it comes to power. So that's only for emergencies, obviously, but in the event of an emergency, you need to know where you need to run to. And then we've got environmental safety. I kid you not, this is an actual topic in a course. If you're laughing at this point in time, well, then I'm glad I've put a smile on your face. If it was up to me, I would actually just skip this, but considering that it's actually part of the official course, I'm going to go for it anyway, just so that it be said that I did cover it. So trip hazards, I think that speaks for itself. So anything that's in your way that can cause you or someone else to trip over it. I think considering that we're talking about IT here, it might very well be something like a network cable, a power cable, maybe a PC box in the way. So try and avoid putting stuff in the way where people can go and trip over it. So you can see there, they mentioned cables, boxes, furniture. I highly doubt that you guys are going to be putting boxes and furniture and stuff in the way. It's possible, but it's more than likely going to be something IT related, like a cable of some kind. That one sounds plausible. Then they mentioned lifting and carrying risks. So lifting heavy objects can cause back injuries. Yes. So if at all possible, if you have something heavy you need to go and pick up, so if it's a heavy PC, a server, or any form of other IT equipment or something related to IT that's heavy, the rule of thumb is try and get someone to assist you. Also, don't lift with your back, lift with your legs and your knees, is what they say. They mention dropped objects can cause leg or foot injuries, so if applicable, maybe wear safety boots. It's unlikely you're going to need to wear safety boots, but if applicable, maybe wear some safety boots. It depends on your environment. Bulky objects can also cause problems. Yeah, maybe if it's a bulky object, it might not be a heavy object per se, but if it's bulky, you might not have a very good grip on it. It's very difficult to carry very big bulky objects if you don't have a good grip on it. So maybe you get a friend, two friends, or someone that's standing nearby just to help you move this object from one point to another. At the end of the day, it's just safer for everybody. The last thing I want to mention to you guys about the topics we've just mentioned just right now, they will not be in the exam. At least the last time I checked, they're not in the exam. So it's just something that you do need to know for the work environment. So if you intend on implementing this in the work environment, which you most likely will, these are good rules of thumb. It's good knowledge to know. But what we just discussed is not in the exam. Some of the stuff is, some of it's not. I will do the best of my ability to try and point them out for you guys, but what we just have on the screen right now is not in the exam. All right, and toxic waste handling. So, obviously, of toxic waste, there's obviously a lot of risks involved. So, if anything is harmful, whether it be toxic waste, electricity, you name it, it's a very good idea to have warning signs up. Wherever applicable, you need to have that up for yourself, just to remind yourself, and also to remind other people that might not know about the dangers involved. You'll see here it mentions contaminants can be gaseous, so there might be potential gases that's given off by these liquids or solids. You never know. So if someone's nearby without protective gear, like a protective mask of some kind, yeah, it might end up in the hospital or worse for all we know. Particulate, organic, poisonous, corrosive. So corrosive, for example, will probably be one if they touch it, it's going to burn their hands. It might be some form of acid. So whenever something like that is not obvious, you might want to go and put a sign up. It just shows them it's corrosive. So if you look at the middle one there on the left, it says corrosive. So if it's a piece of packaging that might have some sort of contaminant inside that's corrosive, yeah, obviously put a label on it so that you know not to go and touch it with your bare hands. Maybe wear some gloves, safety gloves. And if someone else is going to touch it, then at least they know as well. At the very least, they can't sue you because there was a label on it. All right, and there's a few devices we have here that you need to be careful around, such as CRT monitors. I doubt that that's something you guys need to worry about because pretty much anywhere, even in third world countries, you will not really find CRT monitors. So they are for the most part extinct. But they are heavy, first of all, so they can drop on your foot. Although that's not what they have in mind here. It's more about the radiation involved and all of that. So if possible, you do not want to go and open on CRT monitor. Rather just get them an LCD or an LED screen. It's going to be cheaper, it's going to be quicker and easier, safer, not to mention a few things. Batteries as well. I think batteries is something we all know in life, never mind being in IT. Everybody knows a battery is not something to go and play with. One of the things being the possibility that could possibly leak battery acid. Electronic devices such as PCs, cell phones, and tablets, not such a big health risk involved there, not really, but it's something to keep in mind. Toner kits and cartridges, yeah, that is something that you need to keep in mind. That's obviously more serious. Toner is normally something that you'll put into something like a laser printer. It's a form of ink. So cartridges and toner, both of them is ink. So toner is a powder kind of ink, and if you're going to go and replace the toner in a printer or install it for the first time, you need to be very careful there. Preferably wear gloves, if at all possible. Preferably wear a mask and also safety glasses because it's a powder. And in a nutshell, it's basically poisonous to you. So you want to try and avoid, getting that in your eyes or your hands and all that. If you do get it in your hands, just go wash your hands with some cold water. It's not going to kill you if you get it in your hands, but the possibility is there that that dust might go into your lung. You might breathe it in, or you might touch your eyes, after you got it in your hands. So that's why you want to go and wash your hands as quickly as possible. Something I also want to mention regarding toner, just off topic. If you find yourself needing to go replace toner in a printer, it's not a rule, it's not something in the course, it's just a life lesson. I would say maybe just put down some cardboard or something else around that printer, especially if that company or your company has a carpet near that printer. Very, very often, especially if you take out the old toner cartridge, there's always going to be toner dust that's going to be falling on the floor. And if that company or your company's got a carpet there, it's very difficult to get that out of the carpet. It's going to make you look very unprofessional. So learn from my mistakes. I made that mistake once or twice in my life where my clients had a carpet near the printer. And as soon as you take out that old toner cartridge, the powder ink just falls over the carpet and it's very difficult to get out or clean for that matter. So put a piece of cardboard or something there that at least then if you drop some of that powder ink, then, well, you can just throw the cardboard away. It's a lot quicker and easier to go. People are going to laugh at you, but at the end of the day, you're not going to get the carpet dirty. So it's either that or, getting a nasty email to your management. What do you want? All right, so let's talk about ESD, electrostatic discharge. Now, this is something very important, and there's a very good chance you guys are going to get at least one or two questions about this in your exam. So, electrostatic discharge is basically when you, as a human, touch something and you're discharging into that object, for lack of a better term. So, the human body actually contains a very small amount of electricity inside of it, not much. You're not going to feel it, you're not going to break anything unless you touch something very sensitive like computer components. A lot of motherboards these days, RAM chips, and other pieces of circuitry are very, very sensitive, to very, very low voltages. So if you're just going to go ahead and just randomly touch a motherboard, there's a very good chance that you might actually end up blowing something on the motherboard or just blowing the motherboard as a whole. So you want to avoid discharging into a motherboard. The good news is nowadays motherboards are not as sensitive as they used to be in the past. If you go back about 10 years in time to about 2010 or earlier, motherboards, majority of them back then were very sensitive. If you just so much as looked at a motherboard, it'll probably blow. I've obviously been known to exaggerate. Nowadays, you don't even really have to go and discharge. You can actually just touch a motherboard and nothing's going to happen. They're not as sensitive or as sissy like as they used to be, for the lack of a better word. So that's the good news, but it's still a good rule of thumb to go and discharge yourself before touching the components. Now, in this course and an A plus in general, you'll probably hear them talking about, using an anti-static wrist strap and using a rubber mat and all that. And that's what you need to know for your exam. But in real life, you're not always going to have a rubber mat. You're not always going to have an anti-static wrist strap to discharge yourself. So a good rule of thumb would be, and this is just for real life, not for the exam, I would say touch the cabinet itself or the chassis itself of the computer. So if it's a computer chassis, before you touch the inside of the case, before you touch the actual motherboard and the components, touch the inside of the chassis, the actual metal frame. So as you open a computer, stand completely still, touch the inside of the metal case, and that actually allows you to discharge into the case without actually harming the PC. So you're discharging into the metal frame, and as you stand completely still, you can go and, loosen all the parts and all that. That's a good way to go and do it, and that's actually going to help you a lot in life when you don't have a rubber mat or a anti-static fancy wrist strap is what they call it. So that's just going to help you guys. Alright, so as you can see, the next topic is component handling, and ironically now they mention self-grounding, which is pretty much what I just explained to you guys. When you go and touch that metal case, you're releasing that static electricity into the case itself safely. Something you should keep in mind though, if you're going to do that trick of mine, is as soon as you start walking around, especially if it's on a carpet or something like that, you immediately start building up static again. So you want to keep completely still. If you for some reason need to walk away for a few steps, as soon as you get back, get into the habit of just automatically touching that metal frame again of the chassis. As soon as you do that, you're going to discharge again, and then you can start touching the motherboard. It's a difficult habit to build up, but once you have that habit, it's a good habit to have. A few suggestions is using an ESD wrist or leg strap. That is something that you maybe will find only on Google or in fancy organizations, but generally most places I've gone to does not have that. So feel free to go and Google this. If you guys want to know what that looks like, go and go Google, run a search for anti-static wrist strap or leg strap, and then go click on images just to have a look at what the actual images looks like. It's not something you're probably going to really use in real life, but it is something you need to know for the exam. They might ask you, what are you going to go and use to avoid ESD, from blowing motherboards or something like that. And one of the answers will probably be something like a wrist strap or a leg strap or something to do with that regards. They also mention using ESD service mats or smocks. Most often these are rubber mats that you're going to put the PC onto, and you'll find quite commonly that leg or wrist strap of yours will actually connect to that rubber mat. And then lastly, using anti-static bags. Now that actually is something that you're going to use a lot. Whether you know it or not, you might have actually already used one, you just didn't know it. Especially if you go buy yourself new IT equipment. If you're going to go buy yourself a new motherboard, maybe new RAM chips, or anything electrical wise, computer electrical components wise, you'll find that they quite often come in a very weird looking transparent bag. Quite often it looks like a silverish tinfoil kind of looking bag. It's very thick. That bag is actually an anti-static bag to prevent that component from being accidentally blown somewhere along the line, in the form of transport and all that. So who knew, right? So try and keep those bags. If you're going to go buy yourself a new motherboard or new RAM chip or something like that, maybe a new hard drive, and you get that component in a little shiny fancy bag, do not throw those bags away. I normally keep them. I suppose you can throw them away if you want to, but they will actually help you down the line. Put them in a drawer somewhere, maybe in a box somewhere, and one day when you've got a piece of component you need to move, from one point to another, or that you want to give to someone, at least you've got that little baggie that you can go and put it in. Alright, so since we're talking about component handling and rubber mats and wrist straps, here's a picture for you guys. So in case you guys can't find one on Google, here's a nice little picture for you guys. It's a picture of a normal desk, a normal chair, and you'll find that they've actually taken it a little bit further. They actually took the chair and put that on a rubber mat as well with a little strap. And if you look at the desk, there's a rubber mat there, there's a wrist strap for your wrist. Everything here is grounded. I know that is very excessive. I wouldn't go this extreme, but if you have the money and you want to show off, yeah, sure, go for it. But on average, at the very least, you'll maybe find maybe at most a rubber mat on the table, and that's that. A rubber mat on the table with a wrist strap, that's that. Most of the time, I don't even find that. It's just a disc, and there's a PC in that that'll tell you go fix it. You're not gonna find a rubber mat. You're not gonna find a wrist strap or a leg strap. You're not gonna find anything like that. If you do, well, consider yourself lucky because it's not something you find in most organizations. All right, so let's talk system case types. So first of all, desktop computer, a computing device designed to be placed on or near a user's desk. So if you know what a laptop is, well, in the name it says laptop, which means it was designed to be on your lap. The funny thing is, in most cases, if you put a laptop on your lap, it actually smothers the vents, which is not a good idea. So you actually want to have it on a flat surface. Go figure, right? Desktop computers, like the name suggests, was designed for a desk. That's why it says desktop computer. It's normally an actual case that you need to plug into an actual outlet with an actual screen and an actual keyboard, an actual mouse. That is a desktop computer. It's not very comfortable and convenient to go and move them around. Normally only laptops gets moved around along with phones and tablets. A desktop computer, yeah, they're normally fixed to one location. Now, with regards to desktop computers, the actual case where you house the motherboard and the RAM and all the components, what do we call that? That is your system case, or better known as a chassis. It's either metal or plastic. It depends on where you bought it, and if you decided to build yourself, or if you bought it from a computer store of some kind. Could either be plastic, could be metal. Based on my experience, it's normally a mix of the two. It could be plastic and metal for all you know. So that essentially is going to house all your components. Now, a tower case, that's just one of the designs. A system case could actually be square, it could be flat full, it could actually be any shape you desire. As long as all of your components can fit in there, that's a case. A tower case is normally the kind of case you're going to get, which means it's quite tall, but it's also quite slim. So with regards to tower cases, you get full tower cases, mid tower cases, which is probably the average size for the average household, the average office environment, mini tower cases, and slimline. Now, all of those are tower cases you're going to see in your line of work, but I think the most common one you're probably going to be seeing is a mid tower case. That's the most average, most common kind. So yeah, since we're talking about tower cases, here is a picture of a tower case for you guys. So as you can see in the picture, top left hand side is generally where you'll put your power supply. So for most computers, if you open them, you'll find top left hand side is where you'll find your power supply. That, however, is not set in stone, guys. There are exceptions where you might find a power supply somewhere else in your computer, especially of gaming cases. With gaming cases, half of them actually have the power supply at the bottom left. It's the bottom left instead of the top left. It could actually technically be anywhere, but you never know. The most common place you'll find it, however, is when you see that big shiny block, the top left hand side where you plug the power cord into. That is your power supply. The motherboard is the big circuit board where you go and plug in everything. All the little chips and all that which you plug into. That is your motherboard. Bottom right is where you'll slide in your normal hard drives. There used to be these big fat hard drives, but nowadays with solid states on the market, they might not necessarily take your solid state hard drives. You might have to go and put some sort of adapter in there to be able to accommodate your solid state hard drives if you're lucky enough to have one of those fast drives. If you're using the old conventional mechanical hard drives, they're quite big, so they're just going to fit in there. You can either just slide them in. Sometimes you need to go put a screw or two in. Other times they've actually got these little plastic adapters that actually allows you to clip the hard drive in. Top right hand side is where you'll go and put your optical DVD, CD drives, floppy disk drive. If you have one of those lying around, which is very unlikely, but if you have one of those, you can actually put them in there if your system case is one of the old designs. So a little bit more information about system cases. You get small form factor cases. These are very small in size. And only places you'll really find them is maybe in a business like where there's a till point, where you need to go and pay for your goodies. That is some place you might find it. When you place where they need a very small computer that doesn't have to have, high performance. So if it doesn't have high performance, it doesn't need drastic cooling, which means they obviously have a lot more room in it. So it's normally a very cheap PC, a very slimline PC. So I would say a till point is probably a very good example as to where you would find a small factor PC. Then you also have all-in-one units. In some countries you might not find these at all. In some countries you might find them very commonly, and you might find some countries where you'll find them once in the blue moon. In my country, for example, we'll find them, but they're very rare. It's like chicken teeth. You're almost never going to find them. Yeah, forgive the term. So all in one, it looks like a big, fat, oversized screen. Meanwhile, it's actually a computer. So that's why it's so thick. It's because behind the screen, the computer is actually built in behind the screen. It's like a laptop or an oversized tablet, if you will. Alrighty, so let's talk a little bit about the system case design and all of that. So we have the cover, removable portion of the system case that allows access to the motherboard and internal components. So if you stand in front of the computer case, normally on the left hand side, that is where you'll find the cover. The left hand side cover is where it's going to allow you to access the motherboard, the RAM, and the CPU. The right hand side cover can be removed, but that's just going to show you the back of the motherboard, and it's not really going to allow you to do anything. That's kind of useless, for the lack of a better term. So the left one is the one you're normally going to want to go and remove on most computers. So if you stand in front of the computer and you walk to the left of the computer, that cover is the one that they're talking about here. Front panel is a portion of the system case that provides access to removable media, drives, your power switch if you're lucky enough. It actually depends. They say it's in the front, but it actually depends. There are exceptions where you might find the power switches on the top of the case. There is very rare cases where it might be on the side, but it's usually either on the front. If it's like a gaming power case, then it might actually very well be on the top. You might have some fancy lights and fancy indicators on it. You never know. They mention LEDs to indicate driver operation. So generally you'll find quite a few lights on your computer. Some green ones, some orange ones. If you have yourself a fancy case, it might be some blue ones and all kinds of colors of the rainbow. But in a nutshell, they are there to show you whether the PC is on, and they are there to show you when the hard drive is active and all kinds of other things like that. So there's sometimes a little light that only flickers when the hard drive is active. So if you've got something that's active on your hard drive, the light will either stay on or it's just going to blink very quickly. Alright, so since we're talking about the front of the tower case, that's in a nutshell what an average little tower case would look like. Nothing fancy, it's not a gaming case. So on this average computer case, you can see they've got a power button in the front, they've got some basic lights in the front, basic USB ports, everything as default and as common as it gets. What's not so common though is I see here in this picture they've got a little temperature gauge, CPU temperature and fan. You're actually very lucky if you get it on a computer case. A lot of gaming cases don't even have that. That is something you're going to have to really go and look for, So it's very unlikely you're going to have a temperature gauge, CPU, and fan. So I would ignore that one for now. It's not something you're going to get asked about in the exam. So what you're going to find in real life is probably just a power button, USB ports, optical drives, There are exceptions, like I said, power button, USB ports, and those ones could possibly be on the top of the case, not necessarily in the front. Alright, so let's discuss a little bit of information about the back of the system case. We discussed the side and the front. What about the back? On the back, they talk about the rear panel. So the rear panel, this portion of the system case with cut out slots aligned with the position of adapter cards. Now what they don't mention in the A+ course is those cut out ports are unique to each motherboard. So if you're going to go and buy yourself a brand spanking new computer case which is empty, it's got nothing inside of it, the port where the motherboard needs to slide through is actually just one giant big empty hole, and the motherboards that you buy actually comes with that rear little panel where the motherboard slides through. I don't know if you guys have ever wondered, how is it possible that every motherboard looks unique at the back, but yet the ports perfectly align? It's because that little silver panel, if you want to call it that the motherboard slides through, those little holes that it slides through, that actually comes with the motherboard. Do yourself a favor and go have a look at any computer case. That little rectangle, little square plate with the motherboard slide through, that is actually removable. Don't try and remove it unless you're going to actually remove the motherboard, unless you need to remove the motherboard. But if you ever find yourself removing a motherboard, you'll find that little panel, it actually just, you just push it inwards into the case. So once the motherboard's out, from the outside of the case, you just kind of smash it in, and well, it just boom, falls out. And when you want to put a new motherboard in the box of the motherboard, it actually comes with a little panel which you can slide the motherboard ports through. Then we have an adapter card. Circuit board providing additional functionality to the computer system. Yeah, so if you have a computer motherboard that's got limited ports or limited functionality, an adapter card gives your computer additional ports or additional functionality. Maybe it'll give you additional USB ports, an additional PSI ports, something like that. A blanking plate is normally something that's pre-built into your computer. So once you've got a motherboard in, towards the back bottom of your case. So I would say if you're standing at the back of your computer case, normally towards the bottom, you'll find all kinds of little blank metal strips. They look like they're removable because they are removable. Those are blank plates, and they are there to just make sure the airflow is consistent in your case. And they are actually removable in the event of you wanting to go and add some sort of expansion card, like a graphics card, a TV card. Those are actually very rare. A sound card or anything weird like that. If you want to go and add additional functionality to your computer in the form of a card, you will essentially just go and remove that relevant metal plate, and obviously the ports can be exposed to the outside then. So since we're talking about plates and all of that, here's a picture of the back of a computer case. As you can see, where the top is where you would normally find your power supply. As I've said earlier, this could possibly be at the bottom. Now towards the left in the middle, that is where the motherboard is. You can see all the ports, but that little plate, that little rectangle plate where the ports shove through, that plate is removable. So that's the plate that comes with the motherboard. Towards the bottom, you'll find there is two expansion cards. One looks like it's a graphics card, one looks like it's a sound card of some kind. Then below those two cards, there's about 5 slots I see. They're blank slots. Those are the blank plates they're talking about. They're there just to make sure the airflow is correct in your computer. Otherwise, if you're going to go remove them, I wouldn't say your PC is going to overheat, but the airflow is not going to work the way it's supposed to. It might run a little hotter than what it's supposed to, which is going to give your PC, in a nutshell, reduced performance. Not something you want. Alright, and now the topic is to replace or to repair. Now that is a question you're going to face quite a lot in your life. So depending on what the component is, whether it's a desktop, laptop, a server, a tablet, a phone, or whatever the case might be, you might not always have the luxury to go and replace it. You might not always have the luxury to go and repair it. Now, desktops I think is the most common thing you guys are going to be working on, and desktops have very, very many FRUs, which stands for Field Replaceable Units. Basically, any part on a desktop is replaceable. So if you have a desktop PC and the motherboard blows, well, just get a new one. If a RAM chip blows, get a new one. The CPU blows, get a new one. You can replace just about anything on a desktop PC. The same cannot be said about other components. So if you go look at a phone or a tablet or a laptop, some things just are not replaceable, or they're very difficult to get a hold of, or better yet, very expensive to get a hold of. So if it is replaceable, the money that it's going to cost you might not make it worth the while. It might actually work you out cheaper just to go and get yourself a new one. Or for just a little bit extra, you can get yourself a brand spanking new one. So in a nutshell, FRUs is just something that can be replaced, and that's most likely going to be for the most part on desktop PCs. Now with regards to the main topic being replace or repair, yeah, you guys are going to have to make that decision on your own. I can't decide for you. That comes with experience. So I think a very good example will probably be something like that power supply we spoke of earlier. So if you find a desktop PC and the power supply is now blown or broken in some sort of way, you could replace it, but you can also repair it, and you need to make the decision. Are you going to repair it or are you going to replace it? And as I said earlier, in the case of a power supply, it's probably going to be better and safer and cheaper to replace it versus repairing it. It's not always going to be the case, but you will need to make that decision. Alright folks, so a little bit more information about motherboards in general. So as you've probably seen in the pictures we've had a few moments ago, a motherboard is the main piece of circuit board that you'll find inside your computer case. Especially in a desktop, it's very easy to spot. Laptops, not so much. So that motherboard is where you're going to plug everything into. All your cables are going to get plugged into that. Your hard drive, your system case, everything plugs into the motherboard. All your other pieces of circuitry, your expansion cards, your RAM chips, your CPU, everything plugs into the motherboard. That's probably why they've given it the name motherboard, because it kind of houses everything for you. You can see here they mention motherboard types dictates speed and upgrade capabilities. So some motherboards you might find has already reached their capacity. There's no open slots for RAM chips. You can't go and increase the RAM on your PC. And maybe you want to go and replace the CPU for faster CPU, but it might not support a faster CPU. Even though it physically fits into your CPU slot, that does not necessarily mean your motherboard supports it. Your motherboard might very well be too slow to handle the speed of that CPU, for argument's sake. So that motherboard is going to dictate what you can do and can't do. Can you upgrade? Can you not upgrade? Does the motherboard support it? Does it not support it? So at the end of the day, look at your motherboard specs. If you don't know whether your motherboard supports more RAM, for an example purposes, I would say go look at the make of your motherboard, go look at the model of your motherboard, or you can just go and check in the little manual of the motherboard, but you're probably not going to have the manual. So if it's your PC or a client's PC, go to the manufacturer website. You can actually go run a search on Google, type in the make and model. Once you've typed in the make and model, it'll tell you how much RAM that motherboard supports. So the motherboard currently has, let's say, two 4 gig chips in, which equals to 8 gigs. And you want to replace them with two 8 gig chips to increase it to about 16 gigs. You might find that motherboard does not support 16 gigs. It only supports 8 gigs in total. So even if you have the actual chips and even if they fit into those slots, it will not support those RAM chips. The motherboard has its limits. This especially applies to older motherboards. So don't go and waste your money on RAM for you or a client if you have not checked this out first. Very important to check. Alright, and motherboard form factors. This is just something I wanted to throw in here for you guys as an extra. It's not something they will really ask you in the exam. Just for those of you that's curious. So with regards to motherboard sizes, the most common one you guys are probably going to be dealing with is ATX. So if you go grab your average home PC or office PC, the most common motherboard you guys will find is an ATX. It's the one that's normally square and the CPU is kind of like in the top and the middle area. That's an ATX motherboard. Micro ATX, mini ATX, and all these other boards are exceptionally small. Very, very small in size in most cases. And you only find those in like, till points perhaps, or in a library or something, some PC that's very, very small in size. And quite often they've got very limited capabilities. Very slow, very small, in the form of RAM and hard drive and all that. So yeah, that's pretty much the only place you will find those, in case anyone was wondering. So feel free to pause here just to go have a look at it if you need to, but this is not really important for the exam. Now, for motherboard connector types. Now, funny enough, the picture we've got here, that actually is a picture of an ATX motherboard, believe it or not. So that is the most common motherboard you'll deal with, is an ATX motherboard. Now, on this little picture of ours, you can see there's a CPU socket. Now, that's obviously exposed. You're going to have to go and slide a CPU in there. This is still coming up later during the course, but it's not a matter of let's just slide in any CPU. It doesn't work that way. You have to make sure the CPU is the right speed, and never mind the right speed, make sure the CPU has the right amount of pins. So if your motherboard is a socket 775, you need to get yourself a CPU that's socket 775. That is the actual pins on the CPU and the motherboard. So your CPU and your motherboard has 775 pins that need to connect to 100. 775 pins, that's a lot. That's actually a very common CPU chip, a very old one, and I don't even make those anymore, but that was a very common one at its time. Nowadays they're much bigger than that. You can see that in the top, in the middle they've got the memory slots. That's your RAM slots. This motherboard actually has 4 RAM slots. If you go look at your cheaper ATX motherboards, the average ones, they actually just have about 2 RAM slots. This one actually has 4 RAM slots. Towards the bottom right of that motherboard, they've got disk drive connectors. Now if I look at that picture there, that's SATA connectors. So SATA, SATA connectors. Serial ATA is what they call it. So you can see it looks like this one is actually going to plug in from the side, but most ATX motherboards, they actually plug in from the top, not from the side. If you look at that little arrow points toward the bottom, it says adapter cards. That is your expansion cards. So the one that's light gray in color, that is normally a PCIe slot. In other words, that's your graphics card slot. The other ones that's dark gray, those are normally just normal PCI slots, for sound cards, modems, TV cards, that kind of deal. Alright guys, so here's a bit of a close-up for you guys on that motherboard, specifically the CPU side, and then after this I'll maybe do a close-up on the other side. So CPU side, like we've said, your socket size needs to meet. You can't just go and jam in any CPU in there. And once you've got the right CPU for the right motherboard, you can't just go and jam it in there either. You need to make sure that it goes in the right way. You'll find out on one of the 4 corners there's a pin missing. So if you look very carefully, most CPUs on one of the 4 corners has got at least 1 pin missing. Sometimes it's more than 1, but it's usually 1 pin that's missing. And on the motherboard, there's 1 pin missing. That is one way you'll know how the CPU needs to go in there. Also, those little plastic ridges, you might see that in that little CPU slot, they've got these little plastic ridges. In the picture, they're dead center. In real life, that's not the case. You might find on the one side, there's 2 little pieces of plastic that goes inwards. On the other side, it's only 1, and the next side, it's 3. And they're normally off center. The CPU is going to have little holes in the sides as well, which aligns perfectly with those little pieces of plastic sticking out which also allows you to know how it needs to go into. So that's free. That's two ways for you guys to know how to go and put a CPU in. The last one is on top of the CPU, there's a little arrow that points towards the missing pin as well. And sometimes in the slot, it also has a little arrow pointing which side that needs to face to. So that's going to help you guys a lot. You'll find in this picture they've got a lot of heat sinks. That's actually not the case in real life motherboards. So once you've got the CPU in there, there's normally a heat sink you need to put on top of the CPU. So you're going to first apply a little heat paste, which is also known as thermal compound. You're going to put that on the CPU. You're going to put your little fan on top of that heat sink, and that's just going to cool down the heat sink. But around the CPU, there's no heat sinks. Towards the bottom of the motherboard, the bottom half, which you can't see in this picture, there you're going to find a heat sink possibly on the north bridge, and in some cases even on the south bridge, if you guys know where that is. But around the CPU, you're not really going to find heat sinks that commonly. Not like in this picture. Those ones are very, very, very rare. Not something you're going to see. Alright, so we focus to the top of the motherboard. There is your RAM slots. Now you can see it's listed as DIMM, which is double-sided memory. In the old days, we used to call them SIM, which was single-sided memory. Nowadays, it's DIMMs. That's the only thing you're going to get these days is DIMMs. You're going to get DDR2, DDR3, DDR4, DDR5. They're all DIMMs. So you don't have to worry about SIMs. You're never going to find them. They're extinct for the most part. Now your RAM is obviously a form of memory. It's not the only kind of memory your computer uses. Now RAM is volatile memory, which means if it loses power, it forgets what was in the RAM. If you go look at something like your hard drive, that's also a form of memory, but that's non-volatile. So if I, for example, have my PC open and my PC is turned on and I've got a program open on my PC which is installed on my computer, where is that program installed? It's installed on my hard drive, obviously. Now, while that program is out, I want you guys to imagine I yank out the power cable or the power trips in your house or in your office for that matter. Now, obviously, if you start that PC back up again, that program is going to be closed. You're going to have to open it again from scratch. Now, the reason why the program is closed is because the program was loaded into your memory, being your RAM, which is volatile. So as soon as you start your PC and you open anything on your PC, it could be a game, it could be a program, it gets loaded into your RAM. That's very fast memory, but it's volatile. So as soon as you lose power to your PC, whatever was in the RAM gets lost, and you're gonna have to start it open from scratch again to get it into RAM. But you did probably notice that when you start your PC back up, you do not need to go and reinstall that program. Why? Because it's on the hard drive, which is non-volatile. You might not need to go and reinstall it, but you're going to have to, at the very least, start the program back up again so that it loads it from the hard drive into your RAM. We do that because the RAM is a lot quicker. So your RAM can give information to your CPU a lot quicker than what your hard drive can do, which is why it gets loaded from the hard drive into the RAM as needed, and from the RAM it goes to the CPU, and it's just going to feed it to the CPU as needed a lot quicker. Alright, and then just another quickie that I want to throw in for you guys, chipset and memory architecture. So chipset provides communications between different components by implementing various controllers. You would have heard me mention earlier when I was talking about heat sinks that you also get a north bridge and a south bridge on the motherboard. Now this is actually being phased out. A lot of motherboards, actually most motherboards, still have a north bridge and a south bridge, but it is being phased out. So these different kinds of chips you get on your motherboard, those could be your north bridge, could be your south bridge. You'll see there's quite a few mentioned here, and they essentially each has their own little function. One of them could be for video, one could be for sound, one could be for network. Each chipset has its own unique little function on the motherboard. Alright, so let's talk a little bit about CMOS and then also the RTC batteries that gives power to your motherboard or the CMOS, allowing it to remember what it needs to remember. So as you guys can see, CMOS stands for complementary metal oxide semiconductor. Not something you really need to know, not for the exam at least. It's a type of integrated circuit with a wide range of applications, including static RAM. It's used for firmware and flash memory and imaging sensors. It holds basic configuration information, stores system firmware, setup program settings, all kinds of things like that. Now, this includes things like, let's say, your system time on your computer. Have you ever wondered how your PC is able to keep time if you unplug the power? You might find it's 4 o'clock today, and now you unplug the PC, and an hour later when you plug the PC back in, the time is still perfect. How is that possible? It's because of your CMOS. Your CMOS keeps that time, and how it's able to do that is because there's a small little battery. It's a flat little battery you'll find on the motherboard. So here's a picture for you guys of that little coin battery. So if you look at the bottom right there in that picture, that is your coin cell battery that I was talking about. So if that battery is flat, your computer is not going to remember a lot of things. It's not going to remember your boot order. So if you want to start your computer with your CD-ROM first, your optical drive, and then hard drive, and then floppy disk drive and all that, it's not going to remember the boot order. So if your PC starts forgetting the boot order continuously, and if your time keeps falling behind your computer, that is an indication that your motherboard's battery is flat. So yeah, I would suggest just go get that battery replaced. You can buy a new one, they cost nothing. Or if you have an old motherboard lying around that's been blown and the battery's still good, in most cases the battery will still be good, you can just go and yank out that battery from the old motherboard and just replace it on your new motherboard. That's normally what I do. I just go and recycle batteries that's lying around in my house or the office, and I can't honestly think of one time that I had to go and buy one of those batteries. I never buy them. I always have spares just lying around my house or lying around the office. The most common example where I've seen this thing giving issues is if me or a user complains that their time is always wrong on a computer. If that's the case, I can almost guarantee you the battery on the motherboard's flat. They do normally last about 5 to 10 years. On average, it's more than 10 years. For most pieces I've dealt with, they last for more than 10 years, those batteries. Alright, folks, let's talk about expansion slots. Those, for the most part, are those little slots you would find towards the bottom left of the average motherboard. In a nutshell, they give your computer or your motherboard additional functionality. It could be some form of functionality your computer didn't have at all, or it's just going to add on to that. So you can, for example, go and add a NIC, which stands for Network Interface Card. It's a network card. So most motherboards already come with a built-in network card, but if you want to have yourself a second one, or if your current one is faulty, yeah, you can go and use one of those expansion slots. You can alternatively use them to give yourself a sound card if you don't have sound, or if your current one is faulty, or if you just want to go and upgrade your sound, you can do that. Give yourself a TV card. In the old days, we'd also use these ports for modems, dial-up modems. Luckily, those times have passed now. And you can also go and use this for a graphics card. I think that's probably the most popular option amongst most IT people, is to go and use the PCIe slot, which is one of your many expansion slots, for a graphics card. So if you're a gamer, you would probably know what I'm talking about. Alright folks, and then something I just want to mention at this point in time, and we are going to cover it in more depth later on during this course in one of the other modules, is system clock and bus speed. So this is something I would like you guys to familiarize yourself with if you intend on building PCs one day, or just troubleshooting PCs, especially if you want to build PCs, I think. You need to know what the clock speed is and what your motherboard supports. You might even hear at some point in time people talking about terms like FSB, front side bus speed. So your clock speed, as you can see, is generally measured by megahertz or gigahertz. The clock generator initiates timing signal, and the clock multipliers adjust timing signal for different buses. So yeah, it's very crucial that you've got clock speed configured correctly on your PC. You can go and do something called overclocking, which is not actually covered in this course, but it generally involves sending more power to your CPU. In a nutshell, if you send more power, that means more speed. More speed means more heat. So if you're going to go and do that, you need to know what you're doing. You're going to need to have proper cooling, preferably some form of liquid cooling. The old conventional fan with a heatsink might not get the job done then. And if you don't know what you're doing, you could actually push it too far, that CPU, and you could actually end up burning out your CPU or even burning the motherboard in some cases. I've seen people actually overclock a CPU so much to the point where a CPU would actually get so hot it would fall out the other side of the motherboard. It would actually melt a hole through the motherboard. And that is not something you want to experience. So if you don't know what you're doing, it could actually end up in something catastrophic like that. Alright, so let's have a bit of a look at some of those expansion slots you would find on your motherboard. So even the cheapest motherboards normally have some form of expansion slot at the bottom left. The most common one you'll probably find is your normal PCI slot, which is the one we're looking at right now. The normal PCI slot, there's normally at least two of them on the average motherboard. Some motherboards might have three, some might have four. And those normal PCI slots is where you would slide something like a sound card in, your modem in, a TV card. The graphics card, however, is going to be slid into a PCIe E slot. PCIe, the E stands for Express. In the old days, it used to be a different port. I think it was called AGP. And those basically got discontinued around 2009, if memory serves correctly. You can see there in a little picture there on the right hand side, that expansion card. It's got a little piece of plastic sticking out at the back. It says 5 volts, and a little bit piece of plastic sticking out the front. That is a dual power card. Most cards that you want to go and slide into a PCI slot is single power. So it's only going to have a piece of plastic in the front or a piece of plastic in the back, and it's not going to have both of them. If it has both, that means this card is compatible with both. If you look at the picture on the left, that is a picture of the slot. So those little lines at the bottom, you can see the first one says 3.3 volts. That is a card that's only compatible with that one. The other one says 5 volts for the most part. So yeah, if you've got a card that has both pieces of plastic, that's obviously just going to make your life so much easier in a nutshell. Alright, so here's a bit of a picture of that same motherboard I was showing you guys earlier. If you have a look at this picture, the two bottom dark gray slots, the ones that's listed as PCI, those are the ones where you're going to go and slide your sound card in, your TV card, and for the most part, most general cards. The smaller ones there, those are just, additional old ports for old legacy things for the most part. The light gray one there at the top that says multiply 16 with PCIe, that is the sucker you're going to go and slide your graphics card into. If you buy yourself a normal motherboard at a normal price, you're only going to find one of those slots. If you spend a little bit extra, you might find that your motherboard might very well actually have 2, maybe even 3 or 4 of those slots. That is when your graphics card has got slide capability. So you basically go and buy yourself a graphics card, preferably 2 of the same kind. One you'll slide into the one slot, the other one you'll slide into the other slot, and theoretically it's supposed to drastically boost your graphics performance because you've got 2 graphics cards now, splitting the load. If you buy 2 of the exact same card, you would think it's going to go and double your speed, but realistically speaking, and I'm talking from experience here, it generally does not double your speed. You might find it might very well just give you a 7%, a 10%, or a 20% increase. Let's say you're spending $1,000 for one card. Now you're going to go and buy yourself 2 cards, which means you're going to spend $2,000. And what increase are you going to get? Maybe a mere 10% or 20%. Is it really worth it? That's debatable. You might find it might actually work you out less to go and spend only a mere $500 more, depending on what your currency is. Spend $500 more, buy one card, one better card instead of 2 weaker cards. One card that's more expensive, and this card might only cost you a mere $500 more, might very well give you more than a 10 or 20% boost. That card might give you a 50, 40, 50% boost in graphics performance, where if you had 2 of the cheaper card, that would only give you a 10% increase. So it's going to cost you less to buy one card instead of 2, one more expensive card. And if you only have one card, you don't need such a fancy motherboard now, do you? So you can actually get away with a cheaper motherboard. So you're also going to be saving money there. Not really part of the course, but I thought I would throw that in there for you guys as an extra for those of you that are gamers. Alright my homies, so here is the right side of the motherboard, or more specifically the bottom right side of the motherboard. Now if you look at those little ports there that's listed as SATA ports, those are serial ATA ports. And if you look at the one there on the left that says legacy PATA port, that is parallel ATA port. So the P stands for parallel, serial is the much faster one and the much newer one. If you go buy yourself a motherboard these days in the store, I can almost guarantee you 100% you will not find a motherboard that's got PATA ports on it. That for the most part is extinct, which is why they've written legacy there. You might still find these motherboards, but definitely not in a store. Maybe you'll find a user or a client, maybe it's a friend or a family member. It could even be your PC. If your motherboard has those slots, that is PATA. It's the old IDE ports. Most of us in IT would just refer to those as the IDE ports. And depending on how many pins it has, you would normally go and use that for like a floppy disk drive. We don't even get those anymore. Or you would go and use them for an old IDE hard drive or an old IDE CD or DVD-ROM. Nowadays, we just connect everything to a SATA port. So if you've got a DVD-ROM or if you've got a hard drive, you're going to be connecting either or to your SATA port. Now in this example, the cables for SATA is going to be plugged in from the side there, as you guys can see. Towards the top, they actually have an example of what the ports would look like in the inside. It looks like a little L shape. But on most motherboards that I've dealt with, it's actually not plugged in from the side. It's plugged in from the top. The more expensive motherboards normally plug in from the side because it gives your graphics card more room. Normally, the average gamer's graphics card is quite big in size. It's going to go over your SATA ports. And if that's the case, it's going to be very difficult to actually slide a SATA cable in there. It's going to be in the way. Your graphics cards are going to be in the way. Or if you have a SATA cable in there, you're not going to be able to get your graphics card in without damaging the cable of the motherboard. Which is why on more expensive motherboards, you'll find they allow you to slide that SATA cable in from the side. So it doesn't get in the way of the graphics card. They don't interfere with one another. All right, so still the bottom right of the motherboard. It's not necessarily going to be exactly in that spot of the motherboard. So the SATA cables and these little connectors that we've got in a picture there right now, it's just generally going to be somewhere in the vicinity of the bottom right of the motherboard. It's not going to be exactly in those spots. I just want to point that out to you guys. So if you look at those, let's say the first connector there, it says audio headers. Now you might not be able to see it clearly in this picture, but there's actually a pin missing. So if you go and grab yourself the average computer chassis, the average computer case, whatever they want to go and call it, there's going to be a bunch of wires coming from the front panel of that chassis. Most chassis have a bunch of wires coming from the front of that chassis, and that wires, you're going to plug them into these pins. One, sometimes two of them, is going to have to plug into those little audio headers you see there. Quite a lot of motherboards actually has two of those audio headers. So that's going to give your PC sound. It's going to plug the sound system sound in there and all that. If you look at those other two ports that it says 9-pin USB headers. Now you probably would have seen that pretty much any computer chassis has USB ports in the front. If you plug your USB stick or any USB device for that matter into the back of your computer case, you're going to be plugging it into a USB port, obviously, but that USB port is directly on your motherboard. If you plug it into the front of your computer case, is that directly into your motherboard? No, it's not. So how the heck is that connected to your motherboard? Well, you'll find there's a bunch of cables coming from the front of your chassis, and those cables are listed as USB, and you slide those suckers into those ports there that's listed as USB. So when someone now plugs in some sort of USB device into the front of the chassis, it's still going to be as if you're plugging it into the back of the motherboard. Same story, potato, potato. Now way there on the right of that picture, you'll find front panel headers. So there's about approximately place for 10 pins there, but there's normally one pin missing. There's almost always one pin missing. And depending on the motherboard, vendor, depending on the model, you'll find that some of those pins might actually be color coded. So at the bottom of those pins, you'll find that two of them are red, two of them are blue, two of them are yellow, and I think two of them are green. I'm not 100% sure about the last color. But there's definitely a blue one, there's definitely a red one, yellow one, and I just can't remember the last color. I think it might be green if I'm not mistaken. So red, the two red pins is normally your power. So it might actually even have little text written very, very small next to those pins on the motherboard. If it's not, you're going to have to refer to your motherboard's manual. If you don't have that because you lost it or this is not your motherboard, you can actually just go and type the name and make a model into Google and you'll find that same manual online. So now next to those two pins, next to the red, you'll see PWR. It stands for power. The two red pins is what allows your computer to start. So there's going to be a little jumper cable. We call these jumper cables that's going to come from the front of your computer chassis. You're going to slide it over the two red pins. On that jumper cable, you're going to find the text PWR written on it. That means power button. PWR for power. You're going to slide that sucker over the two red pins or whichever two pins are marked as PWR. So what's going to happen is when you press the power button in the front of your chassis or on the top of your chassis, it's basically just two metal points that's making contact. It's like when you turn the key in your car. So what you can actually go and do, and I do not advise you to go and do this because if you don't know what you're doing, you can blow your motherboard. If you take a very, very small flat screwdriver, very small, and you touch those two PWR points with one another, if you touch the one and the other one of a flat screwdriver, basically allowing it to make contact with one another for a brief second, your PC would actually start. It's kind of like jump starting a car. You're jump starting a PC. Looks very cool, but not all motherboards like that. Some motherboards are very sensitive to that. The last time I did that was like 10 years ago, And back then, some motherboards didn't like that. I know Intel motherboards were very sensitive to that. You know, half the time they would blow. And back then, if you grab some other brands like Gigabyte, Asus, those ones, they were a little bit more durable. They wouldn't blow as easily. But that's 10 years ago. So yeah, don't take my word for it. Maybe now it'll work. Still, don't go and try it. So the two blue pins, that's your restart button. So if you press the restart button, that's the two blue pins making contact with one another. Those are the only two that you really need to go and connect is the blue one and the red one. Your restart and your power button. All the other pins is just for little fancy lights in the front of the panel. So when you press the power button, you'll find most computer cases has like some sort of light blue, green, orange, or some sort of fancy lights in the front of the chassis or on the top of the chassis that's just, you know, burning just to show your PC's on. So if you don't connect that one, the lights is just not going to come on. That's all it is. So it's going to say PWR LED. So PWR space LED. So that's power lights is what it stands for. Another one's going to say HDD, hard disk drive is what it stands for. So it's HDD space LED. So that stands for hard drive lights. So there's normally some sort of light, at least one in the front of your chassis that flickers on and off when your hard drive is very active. So if you don't connect that, you're just not going to see the light flickering. And quite frankly, nobody ever looks at that light, including myself. Alright folks, so since we have been talking about USB connectors and all that on the motherboard, the next topic up is USB connectors. Alright folks, so since we've been talking about USB connectors plugging into the motherboard and all that, the next topic is USB connectors. Now, this is probably one of the ports that is the most universal out there. It actually says that in the name, Universal Serial Bus. You can plug just about anything into a USB port. Now here it's listed as 127 devices or up to 127 devices. Now that was at the time of when CompTIA released this version of the course. It's probably way more than that right now. You know, every device these days has a USB port. You go buy yourself a printer, you buy yourself a camera, you buy yourself anything, it has a USB port. It's either wireless or it has a USB port to it. So in the old days, every component would have its own little unique port and it was such an inconvenience. So with regards to USB, what you need to know for the exam is it supports up to 128 devices. That might be a possible question you could encounter in the exam. And just know the various kinds of USB you get. So we're going to go into quite a lot of depth with that, but in reality, all you need to know is you get USB 1.1, which is the old legacy one. I don't think that's even listed in this course as far as I know, but it used to start off with things like USB 1.1, which is very, very old. Another one which is quite common is USB 2.0. That's just an increase in the speed. And then you get what we call USB 3.0. Those are the most common ones that we are all familiar with. USB 2.0 ports, they look the same as USB 3.0. You can plug them vice versa into one another, those devices and those stuff. USB 2.0, however, those ports are black. So you'll find there's a little black in there with little connectors. If it's a 3.0, it's drastically faster in speed, and those ports are generally blue. So if you've got a 3.0 device, the cable connector, the USB connector you would find is blue. So if you want that speed for that device, that 3.0 speed, you need to plug it into a blue port on a computer. If you plug it into a black port, it's still going to work, for the most part at least, but you're not going to get that speed of USB 3.0. It's going to bottleneck it down to 2.0 speed. So you're not getting the full benefit out of it now, are you? So let's get a little bit technical with the USB connectors. So as you guys can see there, USB 2.0 data rate of 480 megabytes shared among all devices attached to a host. So that's probably one of the most common USB ports today, although 3.0 is fast approaching that. There's absolutely no mention in this course of the 1.1. So that magical number you guys see that 480 megabytes per second, that is a number you guys need to remember. There's a very good chance they might either ask you guys that directly in the exam or indirectly. But please make a note of that magic number being 480 megabytes. Any values like that, they love asking that in these exams. Specifically default values, although that one can't really be changed now, can it? You'll find with 3.0, which is the second most common one, super speed mode provides bandwidth of 5 gigabits and a full duplex link, introduces dual subcontrollers to split super speed and legacy devices. So yeah, well, you're not really going to get that speed if you're going to plug it into a 2.0 though. So just remember to plug it into the right port. And then there's a few extra ones there for you guys. As an added extra, I also added there the power that is provided in watts. So USB 2 provides 2.5 watts and USB 3 provides 4.5 watts. That's a whopping lot more now, isn't it? And then lastly, just as another extra for you guys, just to show you guys what some of these USB cables actually look like. I mean, look, there is a lot of these suckers. The chances are very likely that you might not have seen all of these cables, and maybe you'll never even see some of them. Some of them you would have seen, some of them you would not have seen. You would notice some of them actually look like a phone charger or something you would plug into a normal digital camera, not a phone camera, just a normal digital camera. Some of them might be something you would plug into a printer. If you look at the one second from the left, that's actually very common for printers. If you look at the one fourth from the left and maybe even third from the left, those are cell phone chargers, especially the fourth one from the left. So yeah, you might see some of them, you might not see some of them. Alright, and then we have storage connector types. Now, as we've mentioned earlier, you actually theoretically do get PATA and SATA, but PATA hard drives are for the most part extinct. So that is not covered in this course. They strictly only cover SATA hard drives. And that is what the connectors looks like for a SATA hard drive. Now, what we look at there right now, that looks like a normal desktop hard drive, first of all. The connectors, however, for a laptop hard drive and a desktop hard drive are identical. Now, if you go and compare a laptop and a desktop hard drive, you're going to find the average hard drive for a desktop is much bigger in physical dimensions. But with solid state hard drives, those are identical for a desktop and a laptop. So a solid state hard drive for a desktop is the same size as a laptop hard drive. Now that sounds pretty cool now, doesn't it? But it becomes quite tricky to go and mount that sucker inside your chassis, because the average chassis these days was designed for the old mechanical hard drives, the ones that's cheaper, and they were not designed for these much smaller laptop sized hard drives. So when you go and buy yourself one of those hard drives, which all of you at some point sooner or later will go and do because it gives you wonderful speed, where are you going to go and hook that thing up? You're going to have to go and substitute some sort of other hole and just kind of have it dangling there. That's what a lot of us do. Not the best idea, but what can you do? You'll see that they show you what the power connector looks like and what the data connector looks like. The data connector is obviously much smaller than the power connector. The good news here is you cannot fudge it up. You can only connect the data to the data connector. You can only connect the power to the power connector, and there's no incorrect way of connecting it. It's got a little piece of plastic in there in the shape of an L, which prevents you from putting the cable in incorrectly. So there's only one way it can connect to, and only one port it can connect to. So you don't have to stress about putting something in the wrong place accidentally. It's pretty much made idiot-proof, for the lack of a better term. Alright, and then just a little bit extra with regards to storage connector types, just something extra I want to throw in here for you guys. So the one way on the right there, that's Molex. That is the old connector or power connectors you would have for your old DVD and CD-ROMs and your old, well, it's pretty much just your old DVD and CD-ROMs for the most part. The PATA ones, the IDE ones, those ones that's got the old legacy ports. So unless you've got an old computer, you're not going to find that. The one on the left, that is a SCSI connector. So yeah, just something extra, just so that you can identify them if you ever get or come across these in real life. Then we have network connector types. Now this is pretty much guaranteed going to be something you're going to be dealing with in life. Not so much the RJ11, I suppose it depends on your job description, but the one on the left, RJ45, that is definitely something that everybody in IT are going to be dealing with somewhere along the line. You're going to be touching it, you're going to be working with it, you're going to need to know it. So let's start at the one on the left. An RJ11 is what we use for a normal network cable. So that network cable that you plug into your laptop, your desktop, or pretty much any network device like a switch, a router or router, depending on which country you're in, you might pronounce it differently. So I know the Americans pronounce it as a router, and then the rest of the world pronounce it as a router. So yeah, that cable is a network cable. That is an RJ45. The speed of the cable and the category of the cable does not matter. They all use the exact same physical connector in the front, which you plug into the little outlet. It's all RJ45s. So that little transparent plastic connector in the front, it's about 1 centimeter, if you want to go and use the metric system. It's about, I don't know, the size of your pinky nail or your thumbnail. That's the size of the connector. It's transparent. That little connector is the RJ45. Now with network cables, which we're still getting to in a later module that's not covered in this module, you'll learn with cables you get many kinds. You get Cat 3, you get Cat 5, you get Cat 6, and so on. And within these categories, you get subcategories. So with Cat 5, you get Cat 5. you get Cat 5e, you get Cat 6, and you get the idea. There's many cats. These cats actually stands for category. So yeah. Now on the right hand side, we've got an RJ11. That's the old conventional telephone lines. Many countries don't even have these anymore, but if you have a country that's using the old telephone lines, that is a telephone line connector. It's got about 4 little wires in there, possible 4.8 wires. Normally, in most cases, it's not going to actually be 4 wires. It's got 4 connectors, where the RJ45 on the left has got 8 connectors. 8 connectors, guaranteed 8 wires. Right hand side, 4 connectors, but not necessarily 4 wires. A phone can actually work with just 2 wires. Now and then you might see 3 wires. Very rarely have I seen 4 wires. So it depends on how it's all set up in the end of the day. Now, a phone cable is known as a POTS line. POTS. POTS. It's an abbreviation that stands for Plain Old Telephone System. You might wonder, why am I saying it out like that and so slowly? Because that is something they will ask you in the exam. I guarantee it. You need to know what a phone cable is. It's referred to as a POTS line, plain old telephone system. Know it, breathe it, memorize it, write it down on a piece of paper, put it behind your toilet door if you need to. You need to know that stuff off by heart. All connector types you guys need to know for the exam. So in the exam, they will hammer you on connector types. They will hammer you on cable types. That is definitely something I can guarantee you. You need to know that stuff. You need to know it off by heart. Live it, dream it, write it down, whatever you need to. Just get it in your heads. I would say write it down on a piece of paper, put it on your fridge, put it behind the toilet door. So if you're on the toilet, you can see it. Wherever you're going to be sitting a lot, put that wherever so you can see it constantly so you can get it in your head. And then just one last point regarding that telephone cable. Never mind it being called a POTS line, it's actually also called a CAT cable. It's CAT free. So CAT free, being category free, is a telephone cable. CAT 5, 5E, 6, and so on and so forth. Those ones are all network cables, for your PCs, laptops, and that kinds of stuff. And then we've got expansion cards. Again, I know that we did kind of cover this earlier. It was a little bit of a hit and run situation. If you're wondering why I'm going zigzag, that is not my fault. I do apologize, but that is how the course is presented. So I'm trying to keep this as official as possible for you guys, and this is the way the course is structured. So if it goes zigzag, don't shoot me, shoot CompTIA for it. So yeah, anyway, expansion card. A printed circuit board that is installed in a slot on a system board. It's probably going to be the PCI slot, but it might also be a graphics card. Provides special functions for customizing or extending your computer's capabilities, such as your sound, network capabilities, your video capabilities. They make mention of it's also referred to as an adapter card, an IO card, an add-in, an add-on, an expansion card. There's so many names you can give it. It comes in so many flavors. The point is, it gives your computer additional functionality. Now, looking at that picture, I can tell you that picture is actually incorrect. Yes, it's an expansion card. Yes, it slides into a PCI slot. That's a PCI card, to be more precise. And to be even more precise, that PCI card's got dual power, both 5 volts and 3.3 volts like we saw earlier. However, if I look at where they're on the left, it says those are RJ45 ports. Now, from what I've seen, those are not really how they come out. A network card normally only has one port. Very, very, very rarely will you find a network card coming with more than one port. That, my friends, is not a network card. That is a modem. That is an internal dial-up modem by the looks of things. Internal dial-up modems are the ones that have 2 ports like that. They're actually smaller than RJ45 ports. They're RJ11 ports, the ones that takes 2 telephone lines. So one port will be your incoming. So in the old days, if your dial-up modem, which used your telephone line, there would be a telephone cable going into your modem. From the modem, it'll go into your network card, or I should say your modem. So it's going to go into your incoming port on your modem. And from the modem, it'll go out to, I don't know, your phone. That's going to go to your phone, your actual landline, you would use to make landline calls back in the day. Nobody has landlines anymore. So if you do, I don't know where you're staying, but yeah. So that is why it's got 2 ports. One is to come in from the modem to your PC, giving your PC dial-up internet. And then from the PC, it's going to go out back to your, your telephone line, your landline. I suppose this might not apply to all countries, but generally you could not go and make a phone call or be on internet on the same time. It's either or. is if you're on the internet and someone calls you, it would normally drop your connection. That really used to cheese me off so much back in the day. So if grandma calls you, it's like, dear God, grandma, stop calling me. You're making my internet drop. Those were the good old days. And let's have a look at input devices. So you can probably guess what an input device is. That is any piece of hardware, something you can physically touch, that gives your computer, being your laptop or your desktop, information. The most common examples will probably be your mouse and your keyboard. It's not limited to those. It could be something like a webcam that gives a video feed to your computer. It could be a scanner. That is an input device. An output device will probably be something that's giving output, information in the form of output, like speakers, a printer, your computer screen. That is output devices. So in this specific module, we do not cover output devices, but we do in fact cover input devices. So you can see here human interface devices, peripherals that enables the user to enter data and select commands. Peripherals that enables users to communicate with a PC, such as your mouse or keyboard. Not limited to that, obviously. Data entry or command issuance, and keyboard and pointing devices, most common input devices. Yeah, so we know all that. As for keyboards, here's a few examples for you guys. You get them in many shapes and sizes and flavors. If you're a gamer, you probably has one of those fancy keyboards that's got little backlights, and all that fancy. I think some people have got too much money. I don't always have those keyboards because I've got kids, and my keyboards, my kids eat them up for breakfast. They keep eating over the keyboards. They keep spilling drinks on the keyboards. So one day when my kids decide to grow up a little bit, then maybe I can afford to go and buy myself more expensive keyboards. Until then, I'm stuck with cheap keyboards. So yeah, I'm one of the old guys that uses cheap keyboards. So they mentioned the oldest PC input device and still fundamental to operating a computer. There are many different designs and layouts for different countries. Not all countries have got the same designs. And depending on what language your country is, you might find that you are in the United Kingdom and you are one guy's in the United States. They both use English, but United Kingdom English and United States English is not the same. Depending on which one you choose in your computer, it actually affects your keyboard. So if you've got a normal QWERTY keyboard and you go and choose English United States, you might find everything will work fine, for argument's sake. And if you accidentally go and choose English United Kingdom, you might not think it's a big deal because English is English. That actually affects your keyboard mapping. So if I go and press the dot or the comma on my keyboard, it might not give you a full stop or a dot or a comma or a question mark like you would expect. It's going to give you some other random symbol. The mapping is incorrect. So if you ever find yourself in a situation where your keyboard or a client or a user's keyboard is just whack, they tell you they press a key on the keyboard but it's not giving them the symbol or the character they're looking for, just go and check the language of that computer if the language is not perhaps chosen on the wrong country. Specifically, English is one of the culprits for that. And here is one of the places you can go and choose your language. So if you go check the language on your computer, you can see this one's currently on English for United Kingdom. So for argument's sake, if this user is using a QWERTY keyboard and he or she is in the United States or most other countries of the world, if they can choose English for United Kingdom, might not seem like a big deal. And for the most part, I would say about 95-98% of the keyboard is still going to work like normal. But there are going to be certain keys, and some of them, for example, is the dot, the comma, and the question mark. They're not going to be the place where you expect them to be. If you press that key on the keyboard, it maybe shows you a question mark, but you're damn well not going to get a question mark on the screen. So if that's the case, just go and check the language. Then we've got pointing devices. Now, keyboards is probably the oldest one, way back in the day when Windows came out, before it was actually a GUI interface, they only had keyboards. And when they started releasing, the graphical interfaces like Windows 95 and all of that, they added a mouse. A little pointing device that allows you to go and click on icons and pictures and drag stuff around. Makes our life so much easier. But believe it or not, there was actually a time about 25 years ago when we did not always have such luxury. So you get this in many shapes and flavors. The most common kind is an actual mouse that you would have in your hand. But on laptops, you've got a touchpad. Also pretty common. There are also laptops out there that's got like a small little joystick between some of the keys. It's normally somewhere between your little F and G or G and H, somewhere in that vicinity. You find a little joystick. Some laptops might actually have both a touchpad and a little joystick. I personally don't like the joystick, but there's nothing wrong with it. And I think for the most part, they're actually becoming extinct nowadays. You also get roll balls and all kinds of things. Those are pretty much extinct, but if you want, you can go and Google a roll ball pointing device, and you can actually see how some people used to struggle in the past, a roll ball is very inefficient. It just sucks. So yeah, enough about pointing devices and keyboards. I think let's take a look at security input devices. Now this might be a little bit more interesting for you guys. So you can see the picture way on the right. That is a guy pushing his finger onto a biometric finger scanner. So that's the security device. So unless you are that physical person, you are not going to gain access to whatever that is. It's probably going to open a door. So it's a form of authentication, guys. Authentication is proving you are who you say you are. I am the owner to that account. I am the owner to that device. Authentication comes in three categories. Something you know, which is a password or a PIN, for example. Something you have, which could be like a bank card, could be a smart card, could be a FUB, could be your phone, because your OTP is sent to your phone. So an OTP is a one-time PIN. Or it could be some sort of acknowledgement you need to go and do on an application on your phone. And then you get the third category being the last one, which is something you are, which is normally biometric. Something you are will be a fingerprint, an eye scan, voice scan, facial recognition. So those are the different categories you get. And then we have some more security input devices, and I think I'll do one more after this. So there we have a good old-fashioned speed point or pay point, depending on which country you're in. I think most countries refer to that as a speed point. So the average bank card or whatever card you have these days have got a chip built into them. Not all of them, but majority of them. And you'll find that you can actually just go and tap and go it. You just bring that card near the speed point, and in most countries, it's actually going to wirelessly detect that chip and allow you to pay wirelessly. Or you can just go and slide that sucker into that speed point and do the old-fashioned way, if you have to go and do it that way. I think with COVID-19, being in the world right now, a lot of companies and a lot of businesses prefer that you just go and tap and go and not touch their buttons. Depending on what kind of phone you have and who you bank with and all of that, you could actually potentially use your phone these days to serve as if it is a bank card. It generally involves you downloading your bank's app. I think most banks in most countries these days have some sort of banking app. If you have the banking app, you need to configure it correctly, and it's basically a digital card. So your phone is going to act as if it's a bank card, and if you bring it near the speed point, it could actually potentially also pay on behalf of you. Pretty cool. Now, in the beginning, when this wireless tap and go came out, there was obviously a lot of scams that was involved. So if someone brought a speed point near your wallet in your pocket, it would actually take an X amount of your pocket or an X amount of your account without you knowing about it. Because way in the beginning, a lot of banks did not require a PIN. There was no PIN involved when you had to go and tap and go. Nowadays, you can go put a PIN, but it might be limited to a certain value. There's T's and C's. There's always T's and C's in life. And then, guys, the last one for security input devices, signature pad. So yeah, where has the time gone? Nowadays, we do digital signatures. So if you're going to go and write a CompTIA exam, Microsoft exam, or any exam really, a lot of these vendors are going to ask you to go and sign digitally just to make sure that it really is you, or that it really was you if they want to go and audit this afterwards. You can do this to go and apply digital signature to your PC, to a document online. They can be used for so many purposes. But yeah, I can't imagine the world right now without a digital signature pad. Alright everyone, that is pretty much everything for Module 2. If you've got any questions about anything that was discussed in this specific module, please drop your questions in the comment section down below and I will get back to you as quickly as possible. Please give the video a like. I do put a lot of time and effort into these videos. You wouldn't believe how long it actually takes to go and edit these videos and actually make them. And if you're new to the channel, or if you would like to follow the series, otherwise you're not going to know when the next episode comes out, maybe consider subscribing to the channel. Alright guys, I will see you on Module 3.
If you love me, let me know. If you don't, then let me